Have you ever stopped to wonder how your phone knows it's you? Or how your favorite streaming service just seems to, I don't know, read your mind? Well, the secret isn't some crazy magic. It's actually the powerful team-up of probability and statistics. And today, we're going to flip through the playbook that turns all those numbers into the smart tech that basically runs our world.
I mean, really think about it for a second. Your face has its own unique patterns, right? Your viewing history leaves behind this trail of data. Well, probability and statistics are the tools that let computers learn those patterns, guess what you're going to do next, and just make sense of a really messy, uncertain world. It's the secret sauce that helps a self-driving car tell the difference between a person and a shadow.
So our guide for all this comes from David Forsyth's book, Probability and Statistics for Computer Science. And his goal, which I love, isn't to make us all into hardcore statisticians. Nope, it's to show that if you just get the main ideas, you get the keys to a whole set of tools that can make some unbelievably complex problems, well, just kind of disappear.
So where do we even begin? Well, before you can build anything cool, you have to understand what you're working with. And the first, most important step is learning how to see the story that's hiding inside the data. It's about figuring out what the numbers are really trying to tell you.
Okay, so here we've got a simple list of net worths for a few people. Sure, we could do the math and find the average. It's about $108,000. But does that one number really give you a feel for what's going on in this group? Not really. Right now, this is just a boring collection of numbers. There's no story.
But watch what happens when we visualize that exact same data. A histogram doesn't just show you the numbers, it shows you the shape of the numbers. And boom, instantly, a story pops out. You can see this is not an evenly spread out group. Nope. Most folks are clustered way down here on the left, and then you've got this long tail stretching out to a couple people way on the other end. That shape, that's the insight. That's the story the raw numbers could never tell us.
But that first look, as powerful as it is almost never the whole story. So the next skill you got to learn is to ask the most important question in data science, which is simply, why? Why does the data look like this? Because, a lot of the time, the real truth is hiding just one layer deeper.
For example, we've all been told that the normal human body temperature is 98.4 degrees Fahrenheit, right? And if we chart out the temperatures from a big group of people, this chart seems to back that up. All the data is clumped right around that one value. Looks like an open and shut case.
But this is what happens when we ask why. See, when researchers decided to just separate the data by gender, a totally hidden pattern just jumped right off the page. One group consistently runs a little cooler than the other. So that first picture wasn't wrong, it was just incomplete. The real, more interesting story was there the whole time, just waiting for somebody to ask the right question.
So seeing these patterns is step one. But what about all the stuff we can't see yet? How do we think about things that haven't happened, or make choices when we don't have all the facts? For that, we need more than just pretty pictures. We need a formal language to talk about uncertainty. And that language, my friends, is probability.
To really see why we need this, let's try a classic little brain teaser. Let's say you're in a room with just 30 people. What do you think the odds are that at least 2 of them share the exact same birthday? Your gut probably says pretty low, right? Maybe 10, 20%?
The actual answer is a whopping 71%. I know, it feels totally wrong, and that's exactly the point. Our intuition, our gut feeling about chance, is often just plain bad. And this is why we need the hardcore, logical tools of probability to get us to the right answer when our own brain would lead us completely astray.
And you know, getting the right answer isn't just for fun party tricks. Getting probability wrong can have absolutely devastating consequences. A classic and tragic example is something called the prosecutor's fallacy. This is a huge mistake where the odds of some random match are confused with the odds of someone being guilty. It's kind of like finding a really rare footprint at a crime scene and then saying, well, because this footprint is so rare, the person who matches it has to be the killer.
And this is not just a theory. The heartbreaking, real-world case of Sally Clark in the UK is a perfect example. This kind of flawed statistical logic was a major part of why she was wrongly convicted of murdering her 2 children. Her story is just this awful reminder that understanding probability isn't some boring academic thing. It can literally be a matter of life and death.
Okay, so now we have our 2 main pillars, right? First, we have the ability to look at data and actually see the story. And second, we have the language of probability to deal with uncertainty. Once you have those 2 things locked in, we can finally start to build the really smart tools that define modern computer science.
And these tools usually fall into a few big categories. You've got classification, which is all about sorting things into groups you already know. Then there's clustering, which is about finding groups you didn't even know were there. And finally, you have regression, which is all about predicting a specific number in the future. Think of these as the three main power tools in the workshop.
Let's just focus on the two most common ones. Classification answers a "what is it" kind of question. Is this email spam or not spam? It's about putting things into neat little buckets. Regression, on the other hand, answers a "how much" question. What's the temperature going to be tomorrow? What will this house sell for? It's all about predicting a specific number.
Now, these really simple ideas, sorting stuff, finding groups, and predicting numbers, they are the building blocks for all these super sophisticated algorithms. You've probably heard some of these names before: naive Bayes, random forests, k-means. I know they sound complicated, but don't get hung up on the jargon. Just think of them as the powerful engines that are built to do those core jobs we just talked about.
All right, so we have covered a lot of ground here, from simple charts all the way to life-or-death courtroom dramas. So what's the big takeaway? What's the one thing you should walk away with from all this?
It's this. The magic of AI isn't magic at all. It's a logical, step-by-step playbook. Step 1, you learn to see the stories hidden in the data. Step 2, you master the language of probability to handle anything that's uncertain. And step 3, you use those two skills to build powerful tools that can predict, classify, and decide. That's it. That's the foundation of everything.
And I just want to leave you with this one last thought from our guide, David Forsyth. Understanding this stuff isn't just for computer scientists anymore. In a world that runs on data, this is becoming need-to-know information for everybody. Sure, you might need to know more to become an expert, but to make your way in the world today, you certainly shouldn't know any less.